gonna record this because I really want to make the record straight. So some people still haven't done this part. If you are in that group, please contact me as soon as possible. So far, people who are here are losing almost 20 points. If you haven't done this part, so you are losing 20 points. And that is also a good, I mean, it might be a good idea for you to see what is missing. When you go to your portal, I guess, so if you go to your portal in Blackboard and you go to grades, I guess that's where you see all your grades, right? Where is the grades? My grades. So you can see your grades here. So far, I have the sapling, I have the exam, and it should be the test. Did I put the test in? So you should have 3 different grades. Sapling, which includes chapter 2 and 3. Those are 10 points. The exam is 5 points, and Excel is 5 points, right? So in total, so the total number of points that you should have earned this module is gonna be 20. So if you are far away from 20, don't worry too much. I mean, if you complete all your assignments and you have 10 points instead of 20, you are still doing fine. If you are below 10, you should do more. So if you are between 10 and 15 and you believe that you run out of time and need to do to go back and do some work, so please contact me. I might reopen some of the assignments. Probably I will add a penalty for those who are late. So, but I am willing to reopen things. I was looking at the grades and some of them are really low. I'm very happy to see that there are many, many good grades. And when I say many, I mean it. There are grades, many students are between 20 and 18, 20 and 17. So, and many people fall between 20 points and 15 points. So that is very good. So that is very, very good. So I really want you guys to take this more seriously if you haven't done that. And those who are taking the work seriously, I commend you for that work. But yeah, those who are falling behind, please contact me. I really hate to give people bad grades. And believe me, I'm not giving you a bad grade. You are giving yourself a bad grade. I can be helpful, but I need to hear from you clearly. You don't have to explain things. You just ask for help. So, so I was supposed to interview a student today, I guess. We didn't get together. No, I think we were supposed to meet today. But if you are there, I think it's, what's his name? Well, I think you are here, right? I don't see him. Well, if the person who asked me for time is here, please let me know. I will be at the end meeting you. So, so we will talk. So once again, please take this seriously. This is your grade, and that grade always is good to have a good grade. And of course, it's better to learn what we are teaching, but it's much better to learn and have a good grade. Second thing, I don't mind people working together. You can work with a friend, you can work with another person, but it doesn't mean that you have to share your results. So that really means that you are collaborating with a person, you have a question, you know that you have a study buddy, so you can call him and her and just ask questions and see how they approach to the problem. I don't, I mean, I do agree with that because that is the best way to help each other. So if you want to work in small groups, the only requirement is honesty. Do not copy the results. Do not copy the results, and do not copy the results. Get your own results. You can ask questions. People might be happy to work and probably, I mean, I don't know what can be, but it's good to work in groups, okay? So that will help a lot. And if the group, for example, has a specific question, you can ask me questions, and that might be more helpful, because a group of people who cannot figure something out will be contacting me, and that will be very, very effective, okay? So especially when it comes to the Excel assignments, I know many students don't know Excel, they haven't used Excel for years, and even myself, when I do the Excel assignments, I'm always looking for the codes online. So those are things that you don't learn and keep in your mind unless you are using it every day. So Excel is a tool, and there are many sources of information to build those skills. So and you can see that every time I do anything online, I am always checking my Excel. YouTube is very helpful. You type something and you find everything, even if you want to cook something exotic. So so that's the point. You can work in groups. That doesn't mean that you have to copy exchange results. That might be unethical. An ethical thing is to work together and try to find the result, and each other, so they can find the same result, but they are going to find it together. Not you are copying the results from a friend. And secondly, if you work in groups and you need help, I will be here. Even if you work individually, I'm going to be here. Okay. So so basically that was what I wanted to say today. So this chapter is very interesting, because as I mentioned before, so we have different tools that we can use in order to solve problems. For example, if you have the probability of something and you have a sample size and you have a random variable that you want to find out, very likely you can use the binomial distribution. So in some cases today, we're going to look at the Poisson distribution. So in some cases, you can use one or the other. So it all depends on what are the parameters that you are having in your hands. So remember, the binomial distribution, the mean value for the binomial distribution is n times p. So mu is one of the instruments that we can use to determine probabilities using a Poisson distribution. So in many cases, we have to be aware of what we need. So we need to identify the parameters first. So every time you are solving a case, the first recommendation is to see what you have in hands. For example, you start reading the case, like one of the cases that we were looking at. So start by identifying the variables that you have. And of course, you have to read the problem very well, because in many cases they said, oh, use a binomial distribution, or use a geometric distribution. So so that things are very helpful. So so I hope you are able to identify those things. So in the previous cases, we have looked at the binomial. We looked at the geometric distribution and the hypergeometric distribution. Today, we're going to take a quick look at what is the Poisson distribution, right? So once again, all these distributions are tools. Remember, you have your toolbox and you want to fix something. So you go and take a screwdriver or take another tool and you fix the thing. Here is the same. You have a case, you have a problem, and you need to use the right tool to solve that particular problem. So, so today, and I promise a very short class, because to be honest, next class, so let me show you window, no, file. So next class, we only have 6, oh, that's not the one. We don't have 105. Next class, we have like 16 slides. So it's going to be very short. So we are going to identify two different continuous distributions, continuous probability distributions, and we are going to explain the uniform and the exponential. And that is going to serve as a little introduction to the continuous distribution that is the most famous, which is called the normal distribution. So that's going to be next class, and I don't need too much time for that. So I'm trying to be a little bit slow here. So so once again, we are going to go to the so remember, before of that, I also want to I want you to take a look at module 2. So that's the module that we are using. So I uploaded, not uploaded, I put 2 different links, 4 links for the 2 distributions. So if you can watch it over the weekend and more or less have a sense. So those are very easy distributions. Once you find a value, you can compute anything you want. And Excel does it beautifully. So so we just have to conceptualize the problem. So if you can do me a favor and look and watch the videos, it's like 10 minutes one, the other one is 6 minutes. So you can do it in 2-3 days. So that's going to be very helpful. So we are going to be focusing on the examples that we need to revise and the idea behind these 2 distributions. So so please take that into consideration, and we're going to make our lives easier next time. So once again, go to module 2, go to the chapter 5, and just click in one of the links. So there are 4 videos, 2 for the uniform distribution, 2 for the exponential. So I'm probably, after watching the 4 videos, we are going to take also a very short class. So remember that next class, at the end of this of the week, the work is going to be due. Okay. So so now we are going to do the Poisson distribution. So the Poisson distribution is very interesting here. So let me see Poisson distribution. So this is written Poisson, but it comes from a French word, the Poisson distribution. So there are 2 main characteristics of the Poisson experiment. So the Poisson experiment distribution, the Poisson probability distributions give the probability of a number of events occurring in a fixed interval of time or space if these events happen with a known average rate. So this is very important. So what is the average rate? Well, it's the mean. So if you have a case where you have the mean for like, for example, the mean number of students I get every semester is 25. So what is the probability that I will get 35 next year? Well, it might be possible. I can compute that probability. So I need the average and I need the random variable. So so that Poisson probability is very helpful. Like, for example, you are trying to forecast how many more cases of COVID are going to occur in the next couple of months. So you are computing the mean values, and you know that in the month of September, the number of deaths were very low. So you're going to predict that probably that number is going to be. So if the number of deaths is like 30 during the month, so what is the probability that next month we're going to have 25? Well, probably might be possible. So we can include some other parameters so we can compute that particular probability. So so it happens when a known average rate and independently of the time since the last event, right? So the Poisson distribution might be used to approximate the binomial. So that's what I was mentioning. So in this case, if you have so remember in the binomial, so let me make this a little bit bigger. So remember that in the binomial, so you can find the mean value. So the mean value of the binomial is given by the sample size and the probability of success. So for example, if you have to find the probability of an event based on a binomial distribution, you can approximate it to using the Poisson distribution. Why? Well, you already have the mean, so you can use one or the other. So so we can do that at the end. So so here, so the Poisson distribution might be used to approximate the binomial if the probability of success is small, such as 0.1%, and the number of trials is large, like very big sample, 1,000. So N is the number of trials and P is the probability of success. So, so in this case, the Poisson distribution is going to be given by this kind of a strange formula. So that basically means that the value of the mean is going to be exponentiated to the value of the random variable, and then multiply for the exponential of the mu, the negative value of the mu divided by the random variable exponential. So it's kind of not difficult to do. You can do it by hand very easily. If you have a calculator, you can set up the parameters very easy. If you want to do it in Excel, so there is a function that is called exp. So if you want to do this, you do the exp and then the minus of the mean divided by blah, blah, blah. So it's not difficult to do. So you can do it by hand. But also we have a code in Excel that can help me to build not only one value, but help me to build a table that can give me values for the Poisson distribution, right? So if I want to know what is the probability that less than 100, like we were computing 30 cases for COVID, so what is the probability that we find 25 and less, right? So so that can be something that we can do, okay? So so in this case, and we can do it using the Poisson tables, or the Excel version for the Poisson distribution. So here is the notation of the Poisson distribution. So this X means that the random variable follows a Poisson distribution where the parameter is going to be mu, right? So mu is the mean. In many cases, people call mu lambda, which is another name. So, but that is the mean of the interval of interest. So I guess I put a video on your assignments, and that person uses mu, lambda as the mu. So we are used to identify the mean value as mu, but in reality, well, alternatively, some other people use lambda. So you can see some cases where this is correct. So this example is a little bit funny, I guess. I found it, well, not funny, but it's a little bit good, or is good. So let's see what happens here. So Leah answering machine receives about 6 phone calls. So that's the mean value, 6 phone calls between 8 and 10 a.m. So what is the probability that Leah receives more than 1 call in the next 15 minutes? So here we let X to be the number of calls that Leah receives. So the interval of interest is 15 minutes. So in 15 minutes, so here we have the number of times. So it's going to be 8 quarters. So every hour have 4 quarters, 15, 15, 15. And then the second hour is 15, 15, 15. So we have 8 quarters. So the probability that she takes the phone call in one of these intervals is going to be 1/8, right? So in this case, so we have here we have the sample size, or we have the probability. So 15 minutes is 1/8. So we are going to see here that this is 1/8, and this is the number of phone calls that she receives. So in average, she receives 0.75 phone calls each quarter, each 15 minutes, right? So that is the value that we are gonna use. So in this case, so the mean value, once again, is determined by the probability of the event, 1/8, multiplied by the number of events. So this is the number of events, 6 phone calls. So each 15 minutes, she receives in average 0.75 phone calls. I mean, of course, there is not 75 phone calls, but that is in average, right? So now we can write our function. So the random variable follows a Poisson distribution with a parameter mu equal to 0.75. So this number can be any number. Not necessarily has to be some fraction. It can be an integer or any number, right? So we have this case. So we are gonna use, so we can use the Poisson distribution in Excel. So a common application of the Poisson distribution is predicting the number of events over a specific time, such as the number of cars arriving at a toll plaza in 1 minute. So we are gonna use the function in Excel. So we are gonna type Poisson.dist, then I'm gonna write the random variable and then the mean value. So what is the probability that this person, I guess the question was, what is the probability that she's gonna receive more than 1 calls in 15 minutes, right? So so we are gonna use our tables. So here. So we are gonna use, so for this, we need the X, which is the number of events, right? So this is the number of events, and mean is the expected value, expected numeric value, which is the mean value of my, so if we are using, so remember, we can use true to find the cumulative value, or false to find the returns, to find the specific value of that particular event. For example, if I am using 6 here, so I'm gonna say I want to know the probability of that event. So or the number I identified. So so let's do this. So also, before I forget, so the mean value of this Poisson distribution is going to be given by n times p, which is almost is the same number, is the same value, or is the same formula that we are using for the binomial. So the mean can be given, or if it's not given, we need a sample size and a probability to find the mean value. And the standard deviation is going to be given by the square root of this mean value. So let me pull my Excel. Ooh, hold on, that's not good. Don't save. Okay, sorry. So so where is my Excel? Did I send Excel form? I think I did, right?
It's in the email.
It's in the email, right? Excel assignment 4. I think that's not the one. No, that's not the one. Is the
No, that's it. That's assignment 4.
No, I think I have a different. Hold on. What happened is I have,
because Python was all the way at the end of the last tab.
Mm-hmm. So let me double check, because well, I can go. That's the one. Chapter 4 Excel. So far, just let me recapitulate. So we did the expected value, we did the permutations, the combinations, and the factorials. We did the binomial distribution. So that was a long thing also. We did the geometric distribution. So I recommended using either any of these 3 ways to do it. So we have the hypergeometric. So we have to identify So the random variable, and then all these numbers. For example, in this case, this is the number of people in the committee. This is the population that we are targeting. And the last is the total population. So once we identify those, we can be able to build a hypergeometric distribution. So at the end, the Poisson, so it's gonna be the following. So we can do the Poisson here. So is that the one? Mm-hmm. So where is the? Oh, yeah.
Professor.
Yes, young lady.
Can you a little zoom in the Excel word, please?
I certainly can. I certainly can. And thank you for reminding me. Thank you for reminding me. So in this case, let's make this bigger. View, zoom. I'm going to take 150 because we don't have to fill too many tables. So in this case, for the Poisson distribution, all we need is the number of events and the expected value, right? So here, so we need the so this is the so here mu is going to be equal to 0.75, which is the value that we computed here. So remember, the mu is the n times p. So and the probability. So this is a mu. Can you see can you see the Excel or what I'm doing in here?
Yeah.
Okay. So then we have the probability of 1. Okay. So here I'm gonna do the Poisson distribution. So basically it's asking me the number. So in this case is 1. So then we have the mean. The mean is going to be 0.75. So in this case, because it's more, well, I'm going to do it here. So so I'm going to say false, right? So 0.35. So this is 0.35. I guess I was doing this again. So so I use here the formula. So so the formula here was this one. So I replicated the formula here. So I did the probability of x equal to 1. I said, I open a parenthesis, I said mu to the power of x, which is 1, times the exponential of minus mu, which is 0.75, then close parenthesis. I'm going to use another parenthesis here. I like to make sure that things are fine, divided by the factorial of my number, which is 1, right? So so that's basically the same thing, right? So and of course I can use a table. So my random variable is going to be x. My p of x is going to be so there is a possibility that there might be 0, there might be 1, 2, 3, 4, 5, 6, 3, 4, 5, 6, right? So I'm gonna use the Poisson distribution, I'm gonna say the number is gonna be X. So that is the possibility that I have 0. So the probability that I can, with the mean 0.75, and I'm gonna say false because I want the value at each, right? So, so here, I'm gonna use the parentheses, here the parentheses in the B and in the 35, which is this. So I'm gonna drag this down, right? So, so if I want to know, in this case, the probability of more than one, so more than one mean 2, 3, or 4, or 5, 6. So I'm gonna do here the probability of X more than 1 is gonna be equal to the sum of 2, 3, 4, 5, 6. Close parentheses. Okay. So if I want to know the probability of 1, so what is the probability that one phone call is gonna be entering in the next 15 minutes in the first or yeah, in the next 15 minutes. So there is a 35 chance that you are gonna receive a phone call in the first minute. So, but if you want to know what is the probability that you receive more than one phone call in the next 15 minutes, so means that this value, the random variable, is greater than 1. So 1 is not included. So there is a 17%, 17.3%. So we can put these numbers also if you like to work more with percentages. So I like more decimals because I think I can see more the values, and sometimes when I use percentages, I tend to change things, and so I like more decimal points, but some people might use percentages. So we can use here the percentages and everybody's gonna be happy, right? So we can add more zeros. So this is 47%, 35%. So you make your choice. Personally, I like more the decimals because I get less confused, but that is a choice of people doing what they want to do, okay? So here we solve the problem very easily. So once again, for this Excel assignment, so I need to find the mean value as well as what I'm looking for. So what is the value that I want to find? So in this case, I was saying I want to find value number 1. So probably what I can do here, so P, the probability of X greater than 1, So I'm gonna find equal the Poisson distribution of 1 mean 0.75, and instead of saying false, I'm gonna say true because I want to know the cumulative value here. So you see what I mean by that? So I am gonna say true, right? So that means that I have, so this is not the probability, sorry, this is the probability of greater than 1. No, this is the probability of less or equal to 1, right? Less or equal to 1. So if I want to find the probability of X greater than 1, so I'm gonna do the following. I'm gonna do equal 1. I'm gonna use the complement to find the value, right? So we have this value equal to this value. So we can use percentages because we are using percentages and extending the number of decimals, okay? So that is very simple. So once again, the goal for this is to know what we are doing. So am I trying to find the expected value of a distribution when I have a random variable that can be categorized or can be, for example, in this case, 1, 2, 3, 4, 5, I guess was, but I don't, oh, the number of children, right? So that is the number of children. So that is a category. So of course it's children and the number of children. So this is the frequency. So we can use the expected value. So if we have a true failure and success, so we can use the binomial. So in the geometric, we want to find what happens when you are trying. So what is the probability that you succeed in your goal? For example, in the case of LeBron, he always scores in the third one. So you know that the probability of him scoring is like 75% in the third. So you want to know some other type of probability. So you can do it this. You can use this in order to find those values. So so this is what happens. So the failures that you have to go through before you succeed, right? I'm gonna do my test. Well, it's like doing your assignments. You can find your own probabilities of getting your homework done with the highest grade. So you have 3 attempts and you usually get it in the third attempt. So what is the probability that you might get it in the first attempt? So you can use this for many things. So this hypergeometric requires the use of 2 different groups. So in this case, we have a group of men and a group of women. We want to do a committee, and this person, we have 10 women, 8 men. So the population is 18. So, and we want to form a committee of 6 people. What is the probability that we have 1, 2, 3, 4, 6? So here, I have another example that I guess we didn't use. So you can, well, you have to do it on your own. So this case are 2 people and they have different songs, right? So Tom has 10 songs and Tina has 12 songs. So if they travel together in a car, so they can only listen to 3 songs. So what is the probability that if I am Tom, what is the probability that I will get to listen at least or my 3 or 2, 1 or 0 of my songs? So if you are Tina, you have to use change the parameters, right? So this is for Tom. If you were Tina, you were use 12, right? So in this case, guys are gonna do the 10, ladies are gonna do the 12. So you can find the values and you can find this. So the last thing is the Poisson. So we were looking at this, I think. So we also can, for example, in this case of the Poisson, so we can graph our distribution. So I'm gonna graph my distribution. So I'm gonna do, so I'm gonna do insert, I'm gonna do a chart, I'm gonna do a column. So I have my Poisson distribution. In this case, we can see that the Poisson is skewed right. So we can delete the gap in order to make it like a real distribution. So if we find the mean, so the mean of this, so it's gonna be equal to n times p. So n is, that correct? Is that the one that we're doing? So here n, so this is the one that we're doing, right? Hold on, 0.16, okay. So the mean is gonna be equal n times p. right? So N is gonna be 6, and P is gonna be 0.75. So that's my mean. So that the mean value is this. We have the
Professor, can I ask you something?
yes, please. Yes, please.
Do you calculate the 0 or it doesn't calculate? Because it should be 7 with 0, I think.
This one?
Yeah.
Not necessarily, because what you are doing, remember, so remember when this is 0, right? So in this case, you are doing x, so this is mu to the power of 0. So that means this is 1, right? So anything to the power of 0 becomes 1. And this x factorial, when this is 0, remember the property of the factorial, 0 is equal to 1. So that can be defined. It cannot be 0. So even if it was 0 and we cannot solve, so that would be undefined. But this formula allows you to use positive numbers and also 0. So yeah, I know that it's a little bit like confusing, because you multiply something by 0 and it's gonna be 0. But in this case, this 0 becomes this x, so this is gonna be x, right? So this x is gonna be 0, so this is 1, right? Is that clear?
Yeah. But I'm asking about the n. You said n is 6. Do you calculate all the from 0 to 6? It should be 7, right? Or
No, because it's the number of so this is the sample size. So remember, the sample size here, we have 2 hours, right? So that's when I said this is kind of like a little crazy. So we have 2 hours, and the person receives a phone call every 15 minutes. So every hour the person receives 4 and 4, or not? Yeah, 4 and 4 should be 8, right? So probably I made a mistake, because so the sample size. Oh no, here.
So I think you get the 6 from the receive about 6 telephone calls.
Uh-huh.
I think
yes.
Right, that's where you get the 6 from.
So then I guess I made a mistake, right? But I don't think it's gonna change too much, but yeah, that is something that we need to fix. So let me then modify this. So let me erase this. So because the sample size is, but this is the random variable, so we have at least 8. So we can put 8. So so let me so sometimes it's not good to have students who are smarter than the professor. It's always good. So let's do this again. So hold on. So let me edit. So this is good. I think we're fine, right? So so I think we're fine. All we have to do is to. Well, those are the very small probabilities, probably very, very low. Yeah. So but that can be also graphed, right? So, but it doesn't change too much the outcome, because the last ones are so this is in average. So this is in average. So she receives 6 calls in 2 hours, but she receives only 0.75 every 15 minutes. So in this case, I don't think that changed it too much, but I think it's very good to do the right thing. So colon, click format data series, and we're gonna get rid of the cap. Okay. So so what was the question? So in this case, so the number probably is not gonna change that much. So it's gonna be 17 is up to 49, right? 49. Yeah. I mean, it didn't change the number too much. 1734, right? So is that right with everybody? Are you guys fine with this?
Yeah, I guess.
Yeah, I think that's the idea. So so we find the mean, so the mean and the standard deviation. So in this case, the mean, I'm surprised that it's not the mean that we have here. So I was expecting the mean to be in the middle, but or near the tallest bar. That is not the case here. Now the standard deviation, which is sigma, it's gonna be equal to the square root, according to this, of mu, in this case 4.5. Okay. So let me see if we have another example. So so we can find this very easily. So yes, sir.
Another question. I'm sorry about the mean. You multiply n and p. You're gonna change n now, or it's still 6?
Oh, okay. That's a very good point. But yeah, it should be n, should be 8, which is still don't find the yeah, because it's the so in this case, let me think about it. I think that's a very good question, because in order to find the mean value, so we are gonna use we have, so in this case, hold on. So we have the 0.75 and yeah, but I mean, so remember, that's a very good question. Thank you very much. You are absolutely right. So what was the first thing here? So the person receives in average. So we already know the average. So we already know that the average is gonna be 6. So thank you. That was a good thing. So so in this case, so this person receives 6 phone calls between 8 and 10 a.m. So this is the average number of phone calls. So if you multiply, very good point, the probability times the sample size, we're gonna get the mean value. So in this case, it's correct. So we have 6, which is the sample, the mean value. So is that more appealing to you? Who is talking? Nicolene? Is that more likely to?
Yeah, I see.
Yeah, no. Thank you for clarifying.
Thank you, Professor.
Yeah, so we have 8 episodes here. So this is the sample size. So in 8 periods of 15 minutes, so we have 6 phone calls. So so the mean is 6, and the sample size is 8. So the probability is going to be 0.75. So our standard deviation is 2.45. So here we have another case. So I think I did it here. I think I just sketched it here. Leah is answering the phone. That was what I was doing. So you have to add the 7 and the 8 here. And I guess this one is the following. So here we can do the following. So so we already have, so we don't have to create any table. So in this case, so here, imagine that the mean is 7 and you have 9. So here the mean is 7. You have to find the values for 5 values, right? So the mean 0.7, and there are 6 random variables. So find the Poisson values and graph it and do it, do what you need to do with this, right? So in this case, so let me go even lower than this. So this case is very simple. So according to Badin, an email management company, an email user gets 147 emails per day on average. So here very easily, mu is going to be equal to 147. So so we have, let X be the number of emails the user receives per day. So the discrete value takes values from 0 to 147. So the random variable has a Poisson distribution of 147. So so the mean is 147 emails. So this is the random variable follows a Poisson distribution with a mean value of 147. So what is the probability that the user receives exactly 116 emails per day? So this is the probability that the person is gonna receive 160. What are we gonna do? So I'm gonna do the following. So let me do this. So the random variable here is X equal to 160, right? So we are gonna find the probability of this 160, and it says receives exactly 160 emails, right? So so we are gonna do the following. So we are gonna do the following: equal Poisson distribution. It's asking me the X, which is this value, then the mean 147, and then I'm gonna say I want the value at 160. So I'm gonna say false, right? So the probability that a person is gonna receive 160 emails is gonna be 1.8%, right? So so here we have, so what is the probability that the user receives at most, meaning less or equal to 160 emails per day? So this is the probability that the person receives more than 160. So more or equal to 160, right? So that's gonna be the X. So here is the X equal, right? So here I forgot to say X is evaluated at 160, right? So so in this case, I'm gonna find the cumulative. So I'm gonna say equal Poisson distribution. Then I'm gonna take the value. I'm gonna take the mean, and I'm gonna say true. Okay. So this is the value that says what is the probability that you have more than 60, but you want at most. Hold on. So this is the cumulative value of 160. So that is the value. So at most means that 160 and less. So there is an 88.7% probability that the person might receive from 0 260 emails per day, okay? So what is the standard deviation? So we compute the standard deviation as follows, sigma. So we compute the standard deviation. As I said, whoever doesn't look at the values, that is a genius. So the square root of 147, right? So that is my standard deviation. Do I need to compute the mu? No, because I already have mu, okay? So any question? Let me stop the recording.